Hello dear students, welcome back to our channel. Today we'll be covering a very important topic of grade 9. It also forms the basic of your grade 10 first chapter, that is periodic properties. Alright, in grade 9 you studied as periodic table. So today we'll be seeing what is the scope of this chapter, why do we study it at all, what are the topics that we have to be thorough with. Okay, so let's start without wasting any further time. Alright, so periodic table, you all know it is your first chapter in grade 9th, alright, and it also forms the basics of grade 10th, right? So let us start with it. First thing that we are going to see is what are the topics that we'll have to cover. Alright, so the first thing is we have to see the approaches to the periodic classification of elements. How has it evolved over time? सबसे पहले हमको ये देखना है कैसे periodic table आया, कैसे ये over the period of time evolve हुआ, क्या क्या changes हुए. We have to cover all that. Fine. Second thing is Mendeleev's periodic table. Now Mendeleev's contribution in periodic table, we all know that he has contributed the most to it. Okay. Of course, there were some anomalies and there were some drawbacks which were later amended, but it is he who has set the base of periodic table. Fine. Then we have to see the defects in Mendeleev's periodic table, जो काउंसिल में बहुत बार पूछे जाते हैं कि क्या ऐसा एक छोटा सा मेजर फ्लॉ था जिसकी वजह से पूरी पीरियोडिक टेबल हमारी गलत थी और उसको मॉडिफाई करना पड़ा. Then we have to see the salient features of the modern periodic table that was of course changed by Moseley. And then we have to see the types of elements in the periodic table and the characteristics of modern periodic table. Now, whenever we see periodic table, you know, it forms the basis not only of grade 10th and 9th, but also of higher grades. आप जब बड़ी classes में जाएंगे, chemistry पढ़ेंगे, so at that point of time आपको बहुत thorough होना पड़ेगा कि किसी की electronic configuration कितनी है, कैसे हम किसी को element को metal या non-metal classify करते हैं, और बहुत सारी properties आएंगी जिनका नाम आप सुनेंगे gradually in grade 10th, जो मैं अभी नहीं discuss कर रही हूँ, not to scare you at all, but yes, that's how you are going to study it later on. Alright, now first things first, we should know what is the importance of periodic table. Why has it been included in the syllabus at all? और ये question आपको हर chapter में करना चाहिए. Why? ठीक है, not just to get grades or just because the council has recommended something to you. Of course not. So आपको सबसे पहले क्या देखना होगा, आपको देखना चाहिए कि क्यों रखा गया इसको अपने syllabus में, क्यों इसको syllabus का part बनाया गया. So, the periodic table is important because it is organized to provide a great deal of information about elements and how do they relate to one another in a reference, right? This table can be used to predict the properties of all the elements, which I told you. Yes, you will be able to predict the properties of elements if you know their placement in the periodic table. And of course, there are certain elements which have not yet been discovered. ठीक है, like gradually हम और elements discover कर रहे हैं, उनकी places भी हैं, और जो एलिमेंट्स अभी तक डिस्कवर नहीं हुए हैं उनकी प्रॉपर्टीज भी आप प्रेडिक्ट कर पाओगे डिपेंडिंग इफ यू हैव अ क्लियर नॉलेज ऑफ द पीरियोडिक टेबल. ओके, सो लेट अस बिगिन. नाउ यू ऑल मस्ट हैव सीन पीरियोडिक टेबल, सबने देखा होगा एंड आई विल ऑफ कोर्स शो यू लेटर ऑन. बट जो पीरियोडिक टेबल था टैबुलर फॉर्म में आया कैसे? टेबल यू ऑलरेडी नो व्हाट इज अ टेबल. टेबल इज बेसिकली यू हैव अ टाइम टेबल इन द स्कूल, राइट? सो उसमें क्या होता है, टैबुलर अरेंजमेंट होता है, टेबल के फॉर्म में अरेंजमेंट होता है ऑफ योर वेरियस पीरियड्स एंड द टाइमिंग्स, राइट? सिमिलरली जो अपना पीरियोडिक टेबल है उसमें कैसे अरेंजमेंट होंगे? अरेंजमेंट्स आर देयर आर ग्रुप्स, okay, and there are periods. First things that you must need to know is there are horizontal rows in a periodic table which we refer to as of course periods, and then there are vertical columns. आपने कुछ ऐसा सा periodic table शायद देखा होगा, स्कूल में भी देखा होगा, अपने केमिस्ट्री लैब में देखा होगा. So I'll just switch to it now. आपने क्या देखा होगा? I'm just drawing it here. Okay. आपने देखा होगा एक ऐसा सा टेबल होता है, राइट? ठीक, और क्या होते हैं उनमें कुछ ऐसे हॉरिजॉन्टल रोज होते हैं. यस, एंड देन यू हैव सम वर्टिकल कॉलम्स आल्सो लाइक दिस. सो ये जो हॉरिजॉन्टल रोज आपको दिखते हैं इनको हम क्या कहते हैं? इन हॉरिजॉन्टल रोज को हम कहते हैं पीरियड्स. फाइन, वी कॉल देम एज पीरियड्स, राइट? एंड ये जो वर्टिकल कॉलम्स दिख रहे हैं आपको, इनको हम कहते हैं क्या? ग्रुप्स. So these are periods. Horizontal rows are called as periods, और जो आपके vertical columns हैं उनको हम groups का नाम देते हैं. Fine. So this is first thing that you should know before we proceed further, right? Now we will see कि किस किस इंसान ने कैसे कैसे किन किन साइंटिस्ट ने अपने इनपुट्स दिए हैं, कैसे इस टेबल को मॉडिफाई किया है. That all we need to check. So सबसे पहले आए Dobrynius triads. Triad you already know. Triad का मतलब क्या होता है? 3. ठीक है. So Dobrynius triads आया and Dobrynius ने क्या लॉ दिया? He arranged a group of 3 elements which had similar properties of course. ठीक है. It's all about similar properties. Understand this. जो भी periodic table में है, groups में element है, they have similar properties. So he arranged 3 elements with similar properties and of course in the increasing order of their atomic masses. And he called it a triad. उन्होंने क्या किया? 3 एलिमेंट का ग्रुप बनाया और उनको अटोमिक मासेस के हिसाब से, उनके इंक्रीज्ड अटोमिक मासेस के हिसाब से अरेंज कर दिया. और उन्होंने क्या बोला कि जो अटोमिक मास था मिडिल एलिमेंट का, लेट्स से देयर आर 3 एलिमेंट्स A, B एंड C, जो मिडिल एलिमेंट है B, उसका अटोमिक मास किसका अरिथमेटिक मीन होगा? अटोमिक मासेस ऑफ A एंड C. आई विल जस्ट एक्सप्लेन इट टू यू ओवर हियर. जस्ट अ सेकंड. क्या हुआ कि let's say there are 3 elements. Okay, there were 3 elements A, B and C. तो उन्होंने क्या बोला कि A का एटॉमिक मास और C के एटॉमिक मास का जो मीन होगा, जो अरिथमेटिक मीन, और वी कॉल इट एज एवरेज, जो एवरेज होगा वो क्या होगा? वो B के एटॉमिक मास के बराबर होगा. That's what he said. Fine. Later on, of course, इसको contradict किया गया and of course there were it was not true for all the elements. ये सच नहीं था सबके लिए. और उन्होंने केवल ये आप देख सकते हो स्क्रीन पे, लिथियम, सोडियम और पोटेशियम को ग्रुप किया, कैल्शियम, स्ट्रोंशियम, बेरियम को ग्रुप किया एंड क्लोरीन, ब्रोमीन, आयोडीन को ग्रुप किया. एंड ही सेड दैट कि जो लिथियम, सोडियम का, लिथियम और पोटेशियम का जो एटॉमिक मास है विच इज 6.9 एंड 39 रिस्पेक्टिवली, इज द अरिथमेटिक मीन ऑफ सोडियम. इन दोनों का अगर आप एवरेज निकालोगे तो सोडियम का एटॉमिक मास आ जाएगा विच इज 23. सेम गोज फॉर कैल्शियम एंड स्ट्रोंशियम. Same goes for calcium, strontium and barium, also chlorine, bromine and iodine. So these are the elements which he had arranged in groups of 3. लेकिन ये हर एलिमेंट के लिए सच नहीं हुआ, right? It did not hold true for all the elements. And of course, the newer elements were discovered. ये बिल्कुल discard कर दिया गया. So of course, he had tried to arrange elements on the basis of similar properties, but it did not hold true later on. Okay. इसके बाद आया जो सेकेंड अप्रोच था, दैट वाज न्यूलैंड्स लॉ ऑफ ऑक्टेव्स. नाउ ऑक्टेव्स यू ऑल नो, सम ऑफ यू मस्ट बी लर्निंग कीबोर्ड, और आप जिनको म्यूजिक की जानकारी होगी थोड़ी सी भी, मस्ट बी नोइंग दैट वी हैव लॉ ऑफ ऑक्टेव्स इन म्यूजिक आल्सो. सो इट इज सा, रे, गा, मा, पा, धा, नी, सा. सा इज अगेन रिपीटेड, राइट? सो फर्स्ट एंड एथ इफ यू सी दे आर रिपीटेड. ओके, सिमिलरली सो सॉरी, जो न्यूलैंड का लॉ ऑफ ऑक्टेव्स था, इन्होंने बोला कि when elements are arranged according to increasing atomic masses, the physical and chemical properties of every eighth element are similar to that of the first. तो पहले एलिमेंट की प्रॉपर्टी और eighth एलिमेंट की प्रॉपर्टी सिमिलर होंगी, and this he called as law of octaves. Just like in musical notes we have law of octaves, similar was Newland's law of octaves for elements also. अब इसके कुछ assumptions थे और कुछ limitations थे. So this law was applicable for elements with atomic masses up to 40. उसके बाद ये applicable नहीं था. Properties of new elements discovered did not fit into the new law of octaves. So as and when new elements were being discovered, they did not fit into the law of octaves. In fewer cases, Newlands placed two elements in the same slot to fit elements in the table. So of course it was not uniform as well. And he also ungrouped unlike elements in the same slot. So elements which had extremely dissimilar properties, so he had grouped them as well together. Therefore, it was discarded. Again, it was again a systematic approach, but it did not hold true and it had to be discarded. Then came another approach, which is of course, it actually has set the foundation for the modern periodic table. That was Mendeleev's approach, and it is called as Mendeleev's periodic table and law. So he was the first first person who tried creating a table, a tabular chart, okay, for elements. So, and there is a law, Mendeleev's periodic law states that the physical and chemical properties of elements are periodic function of their atomic weights or atomic masses. Okay, so you know, however, it was amended. जो modern periodic law है वो क्या कहता है कि the physical and chemical properties of elements are periodic function of their atomic numbers, not atomic weights. When I come to the modern periodic table, I'll explain to you the difference between atomic weight and atomic number. Of course, you must be aware. ठीक है, number of protons और neutrons का जो weight है, that is atomic mass or atomic weight, और जितने आपके number of protons हैं, which is equal to the number of electrons as well, that is your atomic number. So we'll discuss that later in detail. Now, what are the features of the modern periodic table? Sorry, Mendeleev's periodic table. So, he had created 12 horizontal rows. Okay, later on they were condensed to 7, and these were called as periods. There were 8 vertical columns, which are known as groups. इनका नाम आज भी same है. Groups 1 to 7 were subdivided into A and B subgroups. This also you know. And group 8 does not have a subgroup, and it contains 3 elements in each row. This was of Mendeleev's periodic table, not the modern one. And elements in the same group exhibit similar properties. So now he was able to place elements with similar properties in the same group. This was an achievement, okay? And we'll see what are the achievements of Mendeleev's periodic table. So a systematic study of elements, okay? Elements with similar properties were grouped together. That made the study of chemical and physical properties easier. And there was correction of atomic masses made. So placement of elements in Mendeleev's periodic table helped in correcting the atomic masses of certain elements also. Example, atomic mass of beryllium was corrected from 13.5 to 9. And similarly, indium, gold, platinum were also corrected later on. Now, of course, this table, it provided a prediction of properties of yet to be discovered element. Okay, so a boron, a aluminium, a silicon were the names given to be yet to be discovered elements in a particular group. Okay, and the properties of these elements could be predicted accurately from the elements that belong to the same group. Accurately predicted means you could predict whether the element had been discovered or not. Still, we could predict the properties. For instance, the number of electrons in the valence shell is same throughout the group. Alright, so that's how it could be predicted. And these elements, when discovered, were named scandium, gallium and germanium respectively later on. Now, placement of noble gases was also there, which is again an achievement. So, when discovered, they were placed easily in the new group called zero group of Mendeleev's periodic table, and it did not disturb the existing order. Okay, so zero, still we call them zero, that 8 group as zero group of noble gases, which have stable electronic configurations. Alright. Now, what are the limitations? And because of the limitations only, we had to, go for the modern periodic table that was given to us by Moseley. And the limitations are often asked. Okay, Mendeleev के periodic table का आपसे achievements भी पूछेंगे, and they will also ask the limitations because it is very, very, it sets, you can say, it has set the foundation stone for the modern periodic table. तो council इसके limitations भी पूछती है, इसकी characteristic भी पूछती है, and इसके achievements भी पूछेगी आपसे, ठीक? So the first limitation is position of hydrogen. Now hydrogen, it resembles both the alkali metals and the halogens, okay, in property. So he could not justify the position of hydrogen. Isotopes, atomic weights of isotopes differ, but they were not placed in different positions in the modern periodic table. You already know what are isotopes, okay? Now anomalous pairs of elements like cobalt, they have high atomic weights, but they were placed before nickel in the periodic table. And placement of elements in different groups like platinum, gold have similar properties, but they were placed in different groups. Okay, these are noble metals. And the cause of periodicity. This is the major flaw in the Mendeleev's periodic table. He could not explain the cause of periodicity. He had arranged the elements properly, that was fine, but he could not, justify the cause of periodicity, which was later concluded that actually the only thing was his law was incorrect. Okay, he had stated that physical and chemical properties of elements are periodic function of their atomic weights, whereas it is a periodic function of their atomic numbers. That was later on corrected. And this was the major flaw in Mendeleev's periodic table. So today we have covered the approaches to the development of periodic table, And in next lecture we'll see what how modern periodic table came into force, and what are the limitations and achievements, and who gave it. All right, so that we'll be seeing in, of course, studying together in the next lecture. So I'll see you all again. Take care till then. Bye bye. Thank you so much.